So in today's lesson, what we're going to be looking at is Pythagoras in three-dimensional contexts instead of just two-dimensional, which is what we've been doing. Okay, so the learning intention today is to be able to apply our knowledge of Pythagoras' theorem to three-dimensional problems. And the success criteria is to be able to interpret the question and develop a strategy. That's the key part of this, is actually understanding what the question is asking you to do. And then it's just the same as what we've been doing. So using the formula and substituting and solving, and then that'll help you find the unknown value. For this first example, you can see what we've got here is a rectangular prism. And the question is asking us to find the length of BH. So you can see in this rectangular prism that our vertices have been labelled. And if we find B and we find H, the length BH is going to be the length that runs in a straight line from B to H. Now you can see that actually cuts through the middle of our rectangular prism. Now to be able to find that diagonal length that's running through it, we actually need two other lengths to be able to figure it out. So we need to know what this length here is, running from F to H along the bottom of the rectangular prism. And we also need to know this one going straight up. Okay, so what we're really trying to find, we've got a blue side, a green base, and a red diagonal. That's the triangle that we can see inside this 3D shape. So if I label that, I've got B here, H here, and F in this corner, and F is obviously where our right angle is. Now, some of these dimensions I already know. I already know that this blue one going straight up is going to be 9 because that's what this one is here. So I know that this side is 9 meters. Now this is obviously a side I'm trying to find, but I don't know what this is. Okay, because 6 is going this way and 8 is going this way, but this is going diagonally. So I also don't know what this is. So the first thing I need to do is be able to find out what this green one is. So in order to be able to find out what this green side is, I actually need to look at the base of this rectangular prism. So if I look at the base of my rectangular prism, the base of my rectangular prism is like this. So I've got F, G, H, and E. Like if I was looking down on top of that, and the length I'm trying to find is this one that cuts through here. Okay. Now some of these lengths I already know. So I know E to H is 6 meters. And I know E to F is going to be the same as this side. So that's going to be 8 meters on that side there. Okay. And what I'm trying to find is F to H. So I'm trying to find this one here. I don't know what this one is. Okay. So if we look at this triangle here, we can see it's a right angle triangle. If I'm to label my triangle, I've got an A and I've got a B and I'm trying to find C. So that's the formula I'm going to use. A squared plus B squared is C squared. Okay. So A is going to get changed to 6. B is going to get changed to 8. And then I know 6 squared is 36. And 8 squared is 64. Together they make 100. Remember, we're not done yet. We need to find the square root of that. The square root of 100 is 10. So what I can say about this unknown green side is that that is now 10 meters. It makes sense because it's the longest side, so it's got to be longer than the other two. So now what I can do is I can come back over here and I can change this unknown because I know what this is now. This is now 10 meters. Okay. So this is the triangle that I need to use now. I'm going to make it all red because I'm trying to find the red side. I don't know this, but I do know that this side is 9 meters and this side is 10 meters. Okay? So if I'm labeling again, this is A, this is B, this is C. Remembering A and B are interchangeable. It doesn't matter which one you choose. All right, I'm still trying to find alongside. So this formula works. So A squared plus B squared equals C squared. I'm going to change my A to 10. I'm going to change my B to 9. And then I'm going to do 100 plus 81 is 181. And then I need to do the square root of 181. Will give me C. And then I need to do that on the calculator because I don't know what that is. So the square root of 181 is 13.45 meters. So we have found the diagonal that runs through the center of this rectangular prism. So the first step is to decide on the strategy that you're going to use. So our strategy was to try and find this triangle here. The first thing we did was find the green length. Then we put that back into our original shape in order to find the red diagonal length. All right, so for this second example, we've got William and he wants to pack his 75 centimeter umbrella in his briefcase. If the case's dimensions are 55 by 35 by 25, all in centimeters, will the umbrella fit? So what this question is really asking us, lying flat, it's unlikely that it's going to fit. We can try and work that out to start with to see if lying flat on the diagonal it'll fit, because it definitely won't fit horizontally or vertically according to these dimensions. It might fit diagonally, we'll see. And if it doesn't fit diagonally, we need to think about whether it'll fit diagonally through the middle of the briefcase. So that's what we need to work out first. So I'm going to draw a picture of William's briefcase. So the first measurement I'm going to try and work out is whether it'll fit across the base of the briefcase. So in order to do that, I've got a blue side of a triangle, and then I've got two black sides of my triangle, and that represents these sides here of my triangle. So that means this is 55 and this is 35, and what I'm trying to find is this blue one here. So according to my right angle, this is my hypotenuse. So I'm going to use the formula A squared plus B squared equals C squared. I'm going to do my substitution. So if I make this A and this B, it's going to be 35 squared plus 55 squared equals C squared. I'm going to do that on the calculator. So 35 squared plus 55 squared is 4,250 is C squared. And C is going to be the square root of that. And the square root of that answer is 65.19 centimeters. So we can say that so far, no, his umbrella won't fit because his umbrella is 75 centimeters and across the base, it's only 65 centimeters. So the next thing I'm going to do is I'm going to try and figure out what this measurement is here. Okay, so I'm just going to draw a line around that. So to try and work that out, I've got a blue, I've got a red, I've got a blue, and then I'm just going to keep this black, this one here, okay? That's what I've got there. I'm going to put in my right angle, and I'm going to put in the measurements that I know. So I know now that this is 65.19 because that blue measurement is this measurement down here. And I can see that the black measurement is going to be 25. And so what I'm trying to find is this red one here. And hopefully it will be more than 75 centimeters, so the umbrella will fit. So I'm going to use this formula again because it's trying to find the long side. If I make this A and this B, then it's going to be 25 squared plus 65.19 squared equals C squared. You might not be able to see that. I'll do that on my calculator. I'm just going to do it in one step. Questions like this, it's all right to do it in one step. So 4,874.7361 is C squared. Now I need to do the square root of that to find C. So I'm going to go the square root of 4,874.7361. It's a long number. So I'm just going to do square root of my answer, and that's going to give us 69.82 centimeters with rounding. So you can see that the diagonal is longer than the blue across the base, but however, it's still not long enough to fit his umbrella. So what we have to say is no, it will not fit in the briefcase. I don't think you can see that, but what I've written is no, it will not fit. So that's how we can prove whether his umbrella fits or not. All right, so for our last example, we've been asked to find the vertical height of this pyramid here. So vertical height is actually this one here. Like if you picture right in the middle of the base of the pyramid going straight up, that's the vertical height. So if I'm going to try and find that measurement, then I need a couple of other measurements to try and help me with that. So I need one going from here to the side, and then I also need one going sort of down that face. So if you picture that triangular face, I'm splitting it right down the middle is what I'm trying to find. So if I redraw that triangle out here, like what we did for my other question, just so it gives you an idea of what we're doing, I've got the green base, the red height, and we can call this the slant to make it easier. So one of these measurements we actually know straight away, and that's this green one. So I know that 8 goes from all the way here to here. So to know what the middle out is, that's only going to be 4 centimeters, okay? Because that's half of what the square is. So I don't know what this is. This is the end goal, but this is something that I can find pretty quickly, this orange one. So if I look at this orange part here, what I've got here is a right angled triangle, but it's just leaning over. So we're going to find that one first. So I'm going to draw a whole orange triangle here, and we're going to try and find this side here. That's going to represent this height here. Okay, so I know that this is 11 centimeters because that is this. I also know that this is 4 centimeters again because it's half of that triangle, but I don't know what this is here. Okay, so I'm going to use the formula b squared equals c squared minus a squared because I'm actually trying to find a short side. So if I make this b, this a, and this c, because this is opposite my right angle, so that's my c, that's why I've chosen this formula. So b squared is going to be 11 squared minus 4 squared, which is 121 minus 16, which on my calculator is 105. So to find b, I need the square root of 105, and that is going to be 10.25 centimeters. Okay, so I found the length of this part of my triangle. So I can change this now. I'm going to change this to 10.25. All right, so I still don't know what that red height is. So what I'm trying to find now is this measurement here. So I'm going to again use the formula b squared equals c squared minus a squared, because again I'm finding a short side. So if I make this b, this a and this c, I can change this to 10.25 squared minus 4 squared. So I can do that on the calculator. I've actually got quite a bit of space, so I might do it separately. 10.25 squared is going to be 105.063 minus 16, because I know 4 squared is 16. So I'm going to go 105.063 minus 16, and that's going to give me 89.063. And then to find b, I need to do the square root of this. And the square root of that answer is 9.44 centimeters. Okay. So I need to check if that makes sense. Well, I should have checked halfway if all of it makes sense, but this answer makes sense because it's shorter than 11. This answer makes sense because it's shorter than 10. So you can see from my question that it makes sense that our height would be 9.44 centimeters. So if we think back to today's learning intention and success criteria, it was to develop an understanding of how to use Pythagoras in 3D situations. So what we had to do was interpret the question and find a strategy. So in all 3 questions, we've had a strategy that we've needed to follow because it's been multi-step. And then it's about, again, selecting the right formula, substituting and solving. And if you can do all of that, then you've met today's success criteria.